All right, so today we're going to be starting our inequality unit, and we're going to be talking about our one-step inequalities and how to graph them and how to express them in interval notation. So in this unit, you're going to have three different answers. You're going to solve your inequality, that's one. You're going to graph your inequality, that's two. And then you've got to write your inequality in interval notation, that's three. Okay, so there's three different methods or three different answers you're going to need for each answer, each question. So to solve an inequality, this is basically just like equations, except for one little tiny difference, which I will get to in a second here. But basically, it's the same thing. You got to undo the inequality. The difference here is you have these inequality symbols instead of an equal sign. We just kind of treat them like they're the equal sign when we're solving, but they do mean different things, right? Like we've got your less than or greater than, and you've got your less than or greater than or equal to's. So that have a line underneath of it, that would mean equal to as well. So first of all, let's try solving an inequality. So if we look at this one right here, number 14, got 7n, and this technically means less than, because again, if you think of this like an alligator mouth, alligator's always going to eat the bigger number. So it's eating a negative 112, so that means negative 112 is the greater number. That means this side is less than negative 112. Okay? So we're going to go and we're going to look at that equation. And let's see. So it's 7n less than negative 112. If we want to undo this, this is multiplying, we would do the opposite, which is dividing, right? So we divide each side by 7. Okay, and negative 112 divided by 7 is going to be 16. So I'm going to have n is less than negative 16. Okay, so there's one answer. Now, when we graph it, we need to put a circle at whatever number is here, and depending on what type of symbol, tells me what type of circle. So if you have a regular greater than or less than, those are going to use an open circle. Okay? If you have a greater than or equal to or a less than or equal to, you're going to put a closed circle on those when you graph them. So when we look at this one, looks like we have a regular less than symbol. So we're going to put an open circle at negative 16. And then we're going to draw an arrow basically saying what range of numbers our variable is covering, because that's basically what this is, right? It's a whole range of numbers. It's saying that n is less than negative 16. So that means every number that is less than negative 16 is going to be included in our range. So if we look here, is negative 14 less than 16? No. Negative 12, is that less than 16? No. So if we go over here, negative 18, is that less than? Yeah, negative 20. So our arrow is going to be going to the left. And one just quick observation here is if you're at the end, after you've solved your inequality, if the alligator is going to be eating the number, your arrow is always going to go to the left. If the alligator's eating the variable, then your arrow is always going to go to the right. Okay? If it's eating the variable, that means it's greater than, so it always goes to the right. If it's eating the number, it means it's less than, it means it's going to go to the left. Okay? Not too tough. And then the last thing we need to do is interval notation. So this is another way of expressing the inequality. We've got two ways of expressing it right now, right? We've got our inequality itself. We've got our graph. And then interval notation is another way of expressing it. And interval notation is something that we use quite a bit in math. So this is actually kind of a key piece of information. We're going to use it again a few times in some future units this year. Okay? So interval notation is a way of basically just expressing the interval. And the way it's always written is you do your least number in the interval, and then you write it kind of like an ordered pair, least number, comma, and then the greatest number. So you can see basically the ends of your interval just by looking at the two numbers, right? So if we look at this interval, A lot of students will think, oh, the last number I see is negative 20. That's the least number, right? But look at my arrow. It's still going, right? If we think about it, is negative 30 less than negative 16? Yeah, it is. Is negative 100 less than negative 16? Yeah. Is negative 1,000? Yeah. Negative a million? Yeah, it keeps going on forever, right? So if forever, what's forever as a number? It's infinity, right? And this is the negative infinity because it's going off in the negative direction. So the least number would be negative infinity. And then the greatest number looks like it gets right up to negative 16, right? Now, is it equal to negative 16? No, because we got that open circle, but it gets like infinitely close to negative 16. So we're just going to put negative 16 for now. Now, there are a couple of things we need to worry about with interval notation besides least and greatest number, and that's basically we need to say whether or not that number is actually included in the interval, because like I said, it gets infinitely close to negative 16, but it never actually gets to negative 16. So when you think about it, when you get these really like close numbers, what you represent it with, so anytime you see an open circle type of thing, is you're just going to put a parenthesis next to whatever number has an open circle. Okay? Just a parenthesis, and that would be that. If it was a closed circle, you would use a bracket to show that it is actually included in your range. So that way I can actually see what type of inequality symbols are being used in my interval notation as well. Now, so I'm going to put a parenthesis next to negative 16. Next thing is the negative infinity. So most of us will be like, well, negative infinity is included in your interval, right? But can you ever actually equal infinity? You can't, right? Infinity is a forever number. It's going on forever. So infinities will always, always, always have a parenthesis. Okay, no matter what infinity is, it will always have a parenthesis. Because by definition, you cannot equal infinity. It's a forever number. You can never actually reach it. Okay? Let's look at another one. So let's look at number 16 here. Now, this is going to be the one thing that you got to watch out for inequalities that's different from equations. Notice how this negative 8 here, or this 8 here is negative. Okay? Now, when I divide or multiply each side, so that number going to each side of the inequality, this right here, I'm going to draw little arrows here. Okay? When that number is negative, and let me zoom in even a little bit more. When that number is negative, you have to do something to your inequality. And like anytime you divide or multiply each side by a negative, you should get a big warning alarm going on in your head like, oh, I got to do something. And basically what you have to do is that inequality symbol is going to flip directions. So instead of the r being greater than, it's going to become less than. And then negative 160 divided by negative 8 is 10, right? No. Ugh. 20. Yeah, that makes more sense. Okay. That would be 20. Positive 20. Okay. Now I've got my solved inequality. Now I'm going to graph it. So it's a regular inequality symbol, so I'm going to use an open circle. Okay. And the alligator's eating the number. So that means that the variable is less than the number, so it's representing all these numbers that are less than 20. And then as I look at my graph here, I think of the least number in this interval, it's going to be negative infinity, right? Because it's going off in the negative direction. Greatest number would be 20. Does it equal 20? Nope. So I'm going to use a parenthesis. Can you equal infinity? No. So you're going to use a parenthesis. Okay. And I'll do one more example. If we look at number 18, it's a one-step equation. Now this rule here only applies when you multiply and divide each side by a negative. Here I'm just going to be adding 10 to each side, which means that my symbol is going to stay the same spot. So n is going to be less than or equal to 18. So this is a equal to symbol, so I'm going to use a closed circle. So I've got a closed circle at 18, or a filled in circle. And again, it's eating the number, so it's going to be going to the left. Okay, and then the least number would be negative infinity. Greatest number would be 18. Infinity would have a parenthesis. It actually does include 18, so I'm going to be using a bracket at 18. And I kind of want to do a greater than just to show you guys. So let's do number 20. I'm just going to do it real quick. So we got 14, so we're going to minus 14 to each side. That's going to give me x is greater than or equal to 17. And then it's going to be a closed circle, and x is eating the x, so it's going to be greater than, so it's going to the right. Okay, and then the least number on this interval is actually 17, because it doesn't go below 17, right? So 17 would be my least number, and then the greatest number is positive infinity. Okay, and infinity will have a parenthesis. Does it include 17? Yes, I got that filled in circle. So I've got a bracket next to that. And that is your one-step inequalities.